Our next unit of study is on trigonometry, and you would have had an introduction into trigonometry last year in Math 10, and you would have looked at the different trigonometric functions as they are related to a right-angled triangle. We're going to continue that study this year, and just to remind you, the definition of trigonometry, and this is from Wolfram Alpha, it says that it's the study of angles and of the angular relationships of both planar and 3D figures. So planar would be our two-dimensional figures. And we're going to be specifically looking just at the planar figures or our 2D figures, and specifically triangles again this year. But we're also going to be placing these triangles on our Cartesian coordinate grid. And because it is the study of angles, we want to spend a few classes looking specifically at the angles and how do we describe the angles, and then also how do we describe those angles based on the trigonometric functions that you would have learned last year. So those being your sine, your cos, and your tangent functions. When we talk about an angle, there's different parts of the angle that we actually refer to. So if we have the angle here, our angle would be the portion that's in the middle of what we call our initial side and our terminal side. This point here, remember, is called your vertex. And when we describe an angle, because we've based it on the Cartesian coordinate system, which if you recall is numbered 1, 2, 3, and 4, when we go in this direction, that's actually considered the positive direction. So counterclockwise is positive, and clockwise is going to be negative. For our purposes, we want to look at angles when they are in standard position, because that will be a good reference for us to compare the different trigonometric functions. For an angle in standard position, we want the vertex to be at the origin. So the vertex has to be at the origin. The initial side is the positive x-axis. And then our terminal side is somewhere else within our grid. So this is always going to be our initial, and then we would draw to some other terminal side such as this. So this is the angle, and we could say it is angle theta, and it is in standard position. So for example, for this one, we've gone 180 and a bit more, so maybe this angle is equal to 210 degrees. So 210 degrees in standard position. I've started at the origin as my vertex. I have my initial side being on the positive x-axis, and then I show my angle going counterclockwise, so in the positive direction over, and it would end up in quadrant 3. Again, this one's quadrant 4, quadrant 1, and quadrant 2. When we're looking at angles, we also want to talk about what's called the coterminal angle. So coterminal angles are angles that have the same terminal side. For example, let's say that we have an angle theta that is in the first quadrant. A coterminal angle to this would be, again, starting with our initial side on the x-axis, but we could travel one time around and then come back to the same position. Or we could start at my initial side and go in the opposite direction back towards that angle, which would still get me to have the same terminal arm. So for example, if that initial angle was, say, 50 degrees, going around twice, so if we go around once, that's 360 degrees, plus the 50 degrees, a coterminal angle would be 360 degrees plus 50 degrees, so that would be 410 degrees, is a coterminal angle to 50 degrees. going in the opposite direction. So we've gone, instead of going counterclockwise, we've gone clockwise, so we've done the negative. That would be going around not the full 360, but 50 less than 360. So it would be negative 310 degrees. If we did, say, 2 revolutions around and then added our 50 degrees, that would be another coterminal angle to our 50 degrees. Another term that we use with angles is what we call the reference angle. And if we have an angle that is in standard position, so again, it's got the initial arm, and then we have our terminal arm somewhere else within either quadrant 1, 2, 3, or 4. So if we've got quadrant 1, we could also have an angle that was in quadrant 2. So this angle is theta. This angle here, we could call theta. We could put one in the 3rd quadrant, or we could put one in the 4th quadrant. A reference angle is the angle that is it's a positive acute angle, and it's formed with the terminal side of whatever our theta is and the x-axis. So, for example, my reference angle, and I'm going to refer to my reference angle as theta r. So my reference angle here, again, it's formed with the terminal side, okay, and it is the positive angle. It's an acute angle, so positive means it's going this direction, and that's theta. If we look at our 2nd quadrant here, we want it to, from the terminal side, it needs to form an angle with the terminal side and the x-axis. So terminal side and the x-axis means it's this angle here, and this is going to be theta r. If we look at our 3rd quadrant, so an angle that has its terminal side in the 3rd quadrant, so we want the terminal side to make an angle with the x-axis. This is the x-axis. So this is our positive angle theta r. Finally, if we look at our 4th quadrant, from the terminal side to the x-axis, this would be our reference angle. So theta r in each of these cases is a reference angle for whatever our initial angle was. So for example, let's say we have the angle, so theta equals 280 degrees. The reference angle for 280 degrees, so 280 degrees is going to be in our 4th quadrant. So it would be down here. Okay, so this is 280 degrees. So we need to figure out how would we get up to our x-axis. If this is at 280, then we need to somehow get from 280 up to 360. So 360 degrees minus 280 degrees gives us 80 degrees. So our reference angle is 80 degrees. Take a moment and see if you can figure out how would you determine the reference angle for each quadrant. We saw that in quadrant 4 we would go 360 degrees minus the angle. And so now take a moment and see, can you figure out how would you determine the reference angle for something that is in quadrant 3, or something in quadrant 2, or something that has its terminal side in quadrant 1? Note that with any angle that is in standard position, we can describe it using a point that is somewhere on its terminal arm. So for example, if we have our angle theta here, we could describe that angle and say that somewhere on that terminal arm is the point x, y. We could also draw a triangle, a right angle triangle, and if we have a right angle triangle, then we could figure out the radius of this triangle, especially if we were to continue and form an entire circle around here. So radius here, if this value is x and this value is y, then our radius is going to be x squared plus y squared, but the square root of that using Pythagorean theorem. If we were to reflect this terminal arm in the y-axis, we would end up with a terminal arm, and specifically that point on our terminal arm. The x value is going to be negative, but the y value will stay the same. So our new point on our terminal arm here would be negative xy. Again, we could draw our right angle triangle here. So this angle would be our theta, but recall that the reference angle, theta r, would be actually the exact same amount as our theta over here when we do that reflection. So theta r here is going to equal our theta. And this length is negative x, positive x if we're actually thinking about the value. This height here is going to be y, and again, to find our radius, it's simply going to be x squared plus y squared, which is r. We can continue this and think about what's going to happen in our third quadrant, and the same thing, you're going to have your r, and the only difference being that with this line here, okay, we've done a reflection of our negative xy in the x-axis, so the negative x stays the same, and the y becomes negative now. If we were to consider something in this one where we do a reflection, we can think of this point being reflected in the y-axis, or we can think of this point being reflected in the x-axis, and we're going to end up with our point being positive x and then negative y. With each of these, they will have the exact same radius as the original point. Our reference angle is going to be the same for all of them. So our reference angle will be the exact same for all of them, theta r.